Hello everyone, and welcome to section 2.2 of Precalculus. Today we're moving on to polynomial functions of a higher degree. 2.1 focused just on quadratics, which is x to the second power. Now we're going to do powers that are higher than 2. So quick graph overview. You can make for yourself a bunch of little coordinate planes to get set up here. So if something is to the first power, x to the first, it's going to be linear. If something is to the second power, it's going to be quadratic. If something is to the third power, we call it cubic. If something is to the fourth power, we call it quartic. The fifth power, have you noticed the pattern yet? The fifth power, look, linear has just one direction. A quadratic is to the second power and it has two directions, down and then up. A cubic has, see the power is three directions, up, down, up. Quartic has fourth, down, up, down, up. So you can probably guess fifth is going to go up, then down, then up, then down, then up. 1, 2, 3, 4, 5 directions. And then the sixth power is 1, 2, 3, 4, 5, 6. Obviously, they can change in where they're located, whether or not they are flipped upside down, how steep they are, but this is the very, very general shape. You will notice that even-powered functions, so let's just highlight those, quadratic, quartic, sixth power, even-powered functions are like x squared. Both ends are either up or down. Odd-powered functions are like x cubed. So in linear, notice that, oh, I guess I should change that color. Linear functions start down, end up. Cubic, start down, end up. Fifth power, start down, end up. Or if they were negative, then they would start up and end down. So this little overview here is really going to help you make graphs to already have a sense of what it looks like before you graph it. Here are some facts that you need to know about the graphs of polynomials. Graphs of polynomials are continuous. It means that they don't break, they just have a nice flow, and they're smooth. So you're not going to see things like that. You're not going to see things like that. The leading coefficient so remember, a coefficient is the number in front of the x. That's called a coefficient, where the x is called the variable. The leading coefficient just means it's the one in the lead. It determines the end behavior. So if the leading coefficient is positive, the graph is going to end up. If the leading coefficient is negative, then the graph is going to end down. I can't tell you how it starts. How it starts will depend on whether or not the function is an odd-powered function or an even-powered function. But the leading coefficient does tell you how it's going to end. So I drew all of these with a positive leading coefficient. If you were going to make the coefficient negative, then they would do the opposite. The linear would go down, the quadratic would go down, the cubic would go down. But I don't really want to clutter up the notes with that, so I'm not going to leave it there. The degree of the polynomial, so there's the degree, it means the highest exponent. The degree of the polynomial tells you the maximum number of zeros. It's important that you realize it doesn't tell you the number of zeros, it tells you the maximum number of zeros. For example, if you have y is equal to x squared as a parent graph, that only has 1 0, even though it's squared. But it could have 2 if somebody were to move it down. It also could have no zeros, 0 zeros, 1 0, 2 zeros. So this exponent tells you the maximum number, not how many there are, the maximum number. A 0 is the same thing as an x-intercept. Those two words need to be interchangeable in your mind, zeros and x-intercepts. A 0 is repeated, if a 0 is repeated an odd number of times, called even multiplicity. Oh, we're doing even first. I was going to say. It wouldn't be odd and then called even. If a 0 is repeated an even number of times, it is called even multiplicity, and the graph bounces off the x-axis at that point. So we already looked at one like that. This one only has 1, and it bounces right at the x-axis. Both of the x-intercepts are 0, 0. Where notice these are two distinct ones, maybe -2, 0, and 2, 0. But in this case, x times x, both the factors create the same thing. If a 0 is repeated an odd number of times, called odd multiplicity, the graph kind of flattens out on the x-axis at that point. When I do problems like that, I'll come back to these notes to make sure that that makes sense. And last, an imaginary 0 means that the bump doesn't reach the axis. So here's a cubic function with only 1 0. It has probably some other parts to it, something x squared. It has only 1 0, even though it's cubic, because this one didn't dip down far enough. A cubic could have 3, but sometimes this bump doesn't come down and hit the axis. Or maybe the bump comes down and just touches the axis, like that. That 0 would have an even multiplicity. It happens twice because it bounces. But this is imaginary if it doesn't hit it at all. So I've kind of given you the notes, but honestly, I always feel like kids learn best through examples. So when we do a bunch of examples, I hope to make it all clear. All right, one last little set of notes here, 4 things, and then we'll start actually doing problems. So this, I can't even tell you, this is huge. This is all things that you learned in Algebra 2, but now we really want to solidify them this year. So if x is equal to a is a 0, then x minus a is a factor. X equal to a is a solution of the polynomial f of x is equal to 0. A comma 0 is an x-intercept. And x is equal to a in some books. This one's not quite as important, but you might see it called a root, and I don't want that to confuse you. When I was growing up, they were called roots, not zeros. So there's still some books out there that still call them roots. All right, I'm going to start with this example to give you a sense of what this means. So first, let's factor x squared minus 2x minus 8. Remember, factoring is just reverse FOIL. So the first times the first makes the first. The last times the last makes the last. So I definitely need either 1 and 8 or 2 and 4. There's not that many choices for 8. But the inners and the outers have to add up to -2x. So I'm going to put in a -4 and a +2, because that makes my inners negative 4x when I multiply them, and my outers 2x, which does add up to my middle. How did I get that? I just practiced it a lot, too many times actually. So you'll just get better at knowing how to put those together by practice, but I keep wanting to go over how I factor. Okay, so factoring is a concept that you understand. Now I want you to see how factoring can help you with sketching. I take this polynomial and I rewrite it in factored form. X minus 4 times x plus 2. An x-intercept is always something, comma 0. It's a number. It's where the graph crosses the x-axis. And every single one of those points has an x value, but then the y value is always 0. It has an x value, but the y value is always 0. So if this is something, comma 0, I'm going to make the y, remember this is y, I'm going to make the y 0 and figure out what that x value is that makes this 0. Well, if I want to make this 0, x could be 4. 4 would make the y value 0. Or negative 2. Negative 2 would make the y value 0. So factoring helps you find x-intercepts, 4, comma 0 and negative 2, comma 0. And then the y-intercept is where the graph crosses the y-axis, and that's always 0, comma some y value. So now I can plug a 0 in for the x. I can do it at this step. You're not going to get it wrong from doing it, at this step. Most people don't, but sometimes you do it just by accident. Y is equal to negative 8. But it's just as easy to plug it in here. Y is 0 squared minus 2 times 0 minus 8. The zeros all cancel. So negative 8. Now, this is a parabola. The most important point is the vertex. So it doesn't say that. It just says sketch using the x and y intercepts. But that doesn't mean that you can't just sit there and look at it and say, well, okay, she didn't ask me to find the vertex, but at least I can make a nice graph. It's going to look something like this. Okay, I'm not going to look to see if this point, this vertex, is perfect, but I will say this. Sometimes, so I'm going to write watch out. Sometimes kids plot these and the y-intercept, and then they go like this. That's not the parabola. The y-intercept is not the vertex. So be careful. Nope. Okay, the vertex will be slightly off center. I didn't ask you to find it. You're just making a sketch, but you should be aware. So the third thing I want you to see is you've learned how to sketch, you've learned how to factor, and you've learned how to solve equations. All these concepts are intermingled. If you never learned any of that, if somebody just said, solve the equation, 0 is equal to x squared minus 2x minus 8, what would you do? Actually, I'm going to write this down again. Whenever you see an x squared or higher, set the equation equal to 0 and factor. So 0 is equal to x minus 4 times x plus 2. X is equal to 4 or negative 2. So another little warning today, you're going to have these questions on tests and quizzes. If it says factor, you have to stop here. Sometimes when kids see factor, they write that. That is not factoring. That's solving. Solving means I'm finding the x that makes this equation work. So be careful that you follow the directions: factoring, sketching, solving. If I asked for x-intercepts, these are x-intercepts. Notice that they're written as ordered pairs. If I said find the x-intercepts and you just wrote x is equal to 4 and -2, that would be wrong. X is equal to 4 is a vertical line at 4 when you're talking about graphs. So be careful that you're keeping these three things straight. You've learned all three of them, but now you have to kind of put them together. Factoring, x-intercepts, y-intercepts. So this point, this would be a line if you left it like this. But if I said, what is the y-intercept? You would write it as 0, -8 is the y-intercept. And solving an equation for x. Okay, so here we go. We're going to start making some graphs. First, know your shape. We made a little chart at the beginning of the lesson. Use the leading coefficient to determine end behavior. Remember that if it's positive, it's going to end up, and if it's negative, it's going to end down. Find the y-intercept. It is just too darn easy to find the y-intercept, so take just 1 second and do it. You just have to plug in 0, and you're going to get a number. Find all the x-intercepts by letting y be equal to 0. Find all the x-intercepts by letting y be equal to 0. This usually involves factoring. It's possible it doesn't, but you can be thinking about that. So use a table to plot additional points if you're getting it all stuck, and then draw a continuous curve. Make it nice and smooth. Continuous, smooth curve through the plotted points. All right, let's do some problems. So first, I look at this and I think to myself, oh, I know the shape. It's cubic. But then I see the leading coefficient is negative, and I realize it is cubic, but it's going to end down. So the shape is going to start like that, and it's going to end down. We've got the shape, the end behavior, the y-intercept in this case is 0. When I put a 0 in, they all are 0. So now I know 1 point. And now I'm going to find the x-intercepts. This is usually the big one. So that means you let y be equal to 0. Let y equal 0. And like I said, it usually involves factoring. So 0 is equal, I can take the x out. And I personally really think I'm better at factoring when the first term is negative. So when the first term is positive. So I take out the negative x. That would leave me with positive 4x squared. It does make this a negative 12x, but I just think it's so much easier to factor when the first term is positive. So this is 2x and 2x, the first and the first. It could be 4 and 1. Like I said, it's just practice and how you end up picking them. But for 9, you have a choice between 1 and 9 and 3 and 3. I always pick the numbers that are closest together first. So I try 3 and 3, and sure enough, my inners are 6x, my outers are 6x. If they're both negative, that would work. And if they're both negative, then that would give me a positive 9. So I feel good about my factoring. So there's 3 factors. I let each of them be equal to 0, because when things that are multiplied are equal to 0, one of them has to be 0. So either negative x is equal to 0, or 2x minus 3 is equal to 0, or 2x minus 3 is equal to 0. So divide both sides by -1. So x is 0. So one of my ordered pairs for my x-intercepts is 0, 0. The next one is add 3, divide by 2. So 3 halves will give me a 0. And this one is the same. I don't need to show all the work again. 3 halves come 0. So this has an even multiplicity. That's just the word your book uses. The bottom line is the 0 is repeated. So go back and look at your notes. What does that mean? It means it's going to bounce. I'll show you why. Here's 3 halves, right? I know it needs to come down, and then it needs to go up, and then it needs to come down again. If I went through that point, I would have to come down somewhere else, but there's not another 0. So that should also help you realize that this is going to bounce. It comes down, it bounces, and that way you still only have the 2 zeros. If you actually went through that by accident, you'd have to come down and you'd have a brand new 0 that didn't even exist. Okay. So did we plot additional points? No, if you've got a good enough graph with good shape and the x and y intercepts, you're good to go. Number 2, I see that it's a 4th power, so I'm thinking w, but then I see it's negative, so it's actually going to be an m. Your first step is to come up with the shape. So I have the shape, I know about the end behavior. My next step is y-intercept, so I plug in a 0, and I get 0 again. Now so this was letting x be equal to 0. Now I'm going to let y be equal to 0. 0 is equal to negative 2x to the 4th plus 2x squared. Remember, this will almost always involve factoring. And if the first term is negative, I personally take out the negative. I can take out a 2, and I can take out an x squared. That leaves me with x squared minus 1. I can factor a little bit more. X plus 1, x minus 1. So what would make this equal to 0? If x was 0, that would make this 0. If x was negative 1, that would make this factor 0, which would make the whole thing 0. And if x was 1, that would make this factor 0, which would make the whole thing 0. So I have found the x-intercepts. See, and if you didn't know the shape, it would be really easy to draw that. So you have to think about the shape. And if you're like, well, there's only 3 zeros, I don't know how I'm supposed to draw it with 4. But this 0 is actually twice. It's the factors being squared. Just like this one, you can think of this as squared. If a factor happens twice, that means that there's a bounce. So now I realize, remember, this is my shape over here. I've already thought of it. It goes up, it comes down, it bounces, and then it comes back down again. Very odd little graph, okay? But it's so cool that we can make it a 4th powered graph by doing the x-intercepts, the y-intercepts, and the general shape. Okay, we have one more. So it's to the 4th power, and it's positive. So it's going to be a w. I find my y-intercept by letting x be equal to 0, and I get 0, 0 again. Are you sick of that one? It's not always 0, 0. And then I find my x-intercepts by letting y be equal to 0. This almost always involves factoring. I don't have to take out a negative. My first term is already positive. But I am going to take out an x cubed. So what would cause this equation to be equal to 0? If x was 0, or if x was... So if you can't do this, you don't have to be able to do it in your head. You can do it off to the side. Add 4, divide by 3. But I don't expect to see that work at this point. This is enough. So my x-intercepts, if x is 0, it would be 0. And if x is 4/3, you would have 0. So 0 and then 4/3. So how am I supposed to draw a w through these 2 points? So here's a little interesting thing. If the 0 is repeated 3 times, so that's cubic. That's like x times x times, it is x times, not like, is x times x times x. So when a 0 is repeated with an odd multiplicity, it kind of flattens out there. It's kind of like I'm going to stay on 0 for a little longer. So the graph comes down, and then it kind of stays on 0, and then it comes back up. So it's like a morphed W. It flattened out at the 0, and then it just went through the 4/3. So this is going to mean that it flattens out a little bit there. All right. We are going to write the polynomial functions for each of the following, and then we'll sketch the graph. So find a polynomial function that has -4 and 5 as zeros, which is just another word for x-intercepts. So now you're working backwards. You're saying, well, if -4 and 5 are zeros, then the factors must have been x plus 4 and x minus 5. So it's the same problem, just backwards. We're just going to start mixing it up. Sketch the graph. So there's a 0. Oh, it's really hard to see the axes, so I'm going to fill them in because I made the graph really small. So there's a 0 at -4 and a 0 at 5. So how did we graph before? We knew the basic shape. So this is going to be parabolic without you don't have to multiply it out. You can stop here. You may stop here. You did it. You found a polynomial function. But if this is your polynomial function, what is your y-intercept? If you were to multiply it out, you would get x squared minus x minus 20. So the y-intercept is 0, -20. Did you have to multiply it out to do that? No. You could have found the y-intercept by doing 0 plus 4 times 0 minus 5, and you still would have gotten -20, 0, -20. So either way, my only point is, if you're sketching it and you do this, I am going to mark it wrong because that is not your y-intercept. Of course, are you going to make a huge graph in order to do that? Definitely not. So if you want to graph this, I forgot when I erased it, I was going to do that. So if you want to graph this, -4 and 5, you just have to show, this is what it would look like on your graphing calculator, right? Because it doesn't cross until -20, which you can't see. So if this was your viewing window, you just wouldn't be able to see the bottom. It's the same on a graph. You do not have to renumber these and count by 5s or anything like that. Just literally draw what you would see if this was your graphing calculator. And that's a skill in and of itself. A little bit tricky, but you can do it. Okay. Next one. Find a polynomial of degree 4 that has zeros -5, 1, and 2, and then sketch the graph. So I'm actually going to talk about the sketch. Well, no, we can make the polynomial. So if those are the zeros, then this is the polynomial. -1 and -2. Now, if I plot those, -5, 1, and 2, it says now sketch the graph. Now it's degree 4, so you're going to have to make a W or an M if you choose to make it go down, but most people are just going to keep their lives simple and do a W. But here's what I don't want you to do. Watch out. Some people do this. They make their W. Now they've added a 0. There's no 0 there. They said that the zeros are -5, 1, and 2. You can't invent another 0. So how can you draw something that's quartic but only has 3 zeros? One of them must be a bounce. Pick one to be a bounce. It doesn't matter which one you pick. You have 3 choices. But when you do it, make sure that that's actually where you bounce. So if you're coming down, then you want to bounce there, then that has to be your bounce. 1 has to be your bounce. Or if I had picked 2, so I'm going to erase that and just show you. If I had picked 2 to be my bounce, then I would have had to come down, go up, and then 2 would have been my bounce. You see how you can make different things work? So you have choices. Now, I actually have a really good reason for picking 1. Or I was just going to say, if this is your bounce, don't forget, you must plot the y-intercept. Okay? You do not have to multiply this out. You can stop here. This can be your answer. To find the y-intercept, a y-intercept means 0, comma, a number. So if I put a 0 in, then I get y is equal to 0 plus 5 times -1 times -2 squared. If there's a 0 in there, then this is what you get, which is 5 times -1 times 4, -20. Whew. My y-intercept is 0, -20. What did you cross at? You didn't do it. What did I cross at? I crossed at -3. So you need to correctly do the y-intercept. Okay, this graph would be you get a lot of points, but you wouldn't get that last point because your y-intercept would be wrong. So when you do this graph, we're going to redo it real quick. Here's my axes. Again, I can't reach that y-intercept, and it'd be even lower if you had made the 5 the bounce. So I put my y-intercepts at negative, or x-intercepts here, and my y-intercept is too far down for me to go. So I just go down, and then I show it coming back up, bouncing. I bounced at the 2, and I didn't cross the y-axis. I showed that it keeps going. And that's what it would look like if you had done it on your graphing calculator. The graph would come down, and then it would just disappear, and then it would start to come back up because the y-intercept is lower than you can see. All right, ready for this to get just a little bit harder? So degree 3, oh good, and they told me all 3 zeros. So y is equal to x minus 3 times x minus the square root of 5 times x plus the square root of 5. So I've made a big deal about telling you that you don't have to multiply this out. Right? I don't, you're going to spend all day. You do not want to multiply this out unless you have a square root. Don't leave the square root. Okay? Multiply out just enough to get rid of it. So I have y is equal to x minus 3. So x times x is x squared. My inners and my outers are the same but opposite, so they actually will cancel. That's going to happen a lot with conjugates. And the square root of 5 times the square root of 5 is just 5. Now you can stop. Okay? I still don't need you to multiply it all the way out. You may stop here. I think your book multiplies it all the way out, which is just kind of silly because they don't even have all the same answers anyway. For number 2, answers are going to vary based on which one you square. So you can ask me or ask a friend to make sure that you're doing it correctly. Okay, next section. Finding all the real zeros of each function. So we did that last chapter. We're going to keep doing it. Finding a zero is just a fancy terminology for finding the x-intercepts. And how do we find the x-intercepts? X-intercepts are always a number, comma, 0. And since this is y, the y is going to be 0. Finding the zeros, it literally could have just said solve this equation equal to 0. Same thing. So I'm always trying to sell you on the importance of factoring. It's huge. Now I'm going to tell you how much I like factoring when there's 4 terms. Love factoring when there's 4 terms because it makes my first, outer, inner, last. I mean, think about it. FOIL has 4 parts. It makes sense that factoring with 4 would be nice. So the first times the first makes the first. Well, it's got to be x squared and x. I mean, I guess it could be 1 and x cubed, but it's never going to be that. Now, here's the cool part. The last times the last makes the last. Do you know how many choices there are? 1 in 100, 2 in 50, 4 in 25, 5 in 20. Okay, only 4 choices. Maybe there's more. 10 in 10, because there's got to be some more. 10 in 10. So there's choices. But what's great about when you see 4 terms is you can literally see the inners and the outers. So here's your inners and your outers. And here's your inners and your outers. So something times x has to make one of these two. Well, to make an x, I need it to make a negative 25x. There's my inners. And if that's a negative 25, then to make the 100, this needs to be a negative 4. And sure enough, outers, x squared times negative 4 is negative 4x squared. So it really is great when there's 4. I know you probably learned grouping, factoring by grouping. You can do it that way. I'm not against factoring by grouping. But why learn a new skill set? If you can do all factoring in the world using reverse FOIL, that's what I would do personally. Okay, so I factored, and now I have to factor some more. So I get 0 is equal to x plus 5 times x minus 5 times x minus 4. So my zeros are negative 5, positive 5, and 4. If they had said specifically what are the x-intercepts, you would have had to list them as an ordered pair. But with zeros, people are willing to let you just say negative 5, 5, and 4. Okay, next one. By the way, look how fast we can graph this. Negative 5, 5, 4. It ends up. It's cubic, and its y-intercept is somewhere at 100. So it literally goes up. It goes up to 100. It comes back down, and then it goes back up again. Okay, so very, very easy to graph. Factoring, zeros, it's intercepts, all related. Okay, find these zeros. Don't forget that when you're factoring, you should always factor out first. Factor out first. So I can take a 2 out. It's not that you can't factor if you don't do this, but it's just going to make your life so much easier. So you could break this down into x cubed and x, but you can see that there's no x cubed and x's in the inners and the outers. So you want to stick with the x squared. And the inner is going to be something x squared and another something x squared, which has to make -1 x squared. I made a little random mark there, sorry. Which is going to be -1 x squared. My choices for 20, 1 and 20, 2 and 10, 4 and 5. I always start with the ones that are closest together, unless I can see that it's going to be something different right off the top. But I try 5 and 4. That gives me 5x squared and 4x squared. I need to end up with a -1x squared, which I can do if I make the 5 negative and the 4 positive. So this is positive and this is negative. Now I can't factor either of these anymore. That doesn't mean you can't, you can stop. So there's 3 factors. Which one is not causing the equation to be equal to 0? This first one. 2 is not equal to 0, so you can ignore that. So either x squared minus 5 is equal to 0. I'm actually just going to write that so you have it in your notes. 2 is not equal to 0. Or x squared plus 4 is equal to 0. X squared is equal to 5. X is equal to, don't forget your plus or minus. Plus or minus the square root of 5. Don't forget your plus or minus. And on this one, you get x squared is equal to -4. Can we take the square root of a negative number? No. So it is going to end up with an I in it. You probably remember, like, oh yeah, I kind of remember that. But we don't relearn it in precalculus until section 2.4. So for right now, the directions are going to say find all the real zeros. So since this is imaginary, you don't have to list that as your answer. These are the only real zeros. So I don't expect you to suddenly remember exactly how I's work. We'll do it on, when we do section 2.4. All right, we have 2 more. Hang in there, you're doing great. I set the equation equal to 0 to find the zeros, and I factor out first. I can take out an x, which leaves me with x to the 4th plus x squared minus 6. I'm going to break that down into an x squared and an x squared because I look to the inners and outers and see that there's an x squared there. 6 could be 1 and 6 or 2 and 3. I always start with the numbers that are closest together as my first guess if I'm just guessing and checking. You don't have to make these little loops if you're an awesome factorer, but I do find that this helps some people. I have a 3x squared and a 2x squared, and I'm trying to make an x squared. So if this were positive and this were negative, that would make a 1x squared. So 3 is positive and 2 is negative. I do erase all of that. I don't keep my inners and outers. So I have 3 factors that are equal to 0. Either x is equal to 0, or x squared plus 3 is equal to 0, or x squared minus 2 is equal to 0. This one, when I start to solve it, I would be taking the square root of a negative. So this is not real. And today, we don't have to include it. We will in just a week. X squared is equal to 2. X is equal to, don't forget, plus or minus. Easy to forget. So my answers are, the zeros are 0 and plus the square root of 2 and minus the square root of 2. If I asked for x-intercepts, you would list them as ordered pairs. But with zeros, you can just make a list. I always get the question, can I just write it as 0 and then plus or minus the square root of 2? Absolutely. Okay, that's fine. But you better understand what it means, that there's two distinct answers there. Okay, so I put this last one on here because sometimes there's some confusion about clearing fractions. I get kids so into it that sometimes they do it at the wrong spot. If this were just a graph, you would not be allowed to clear the fraction because that would then have no longer be y is equal to. Then you'd have 2y is equal to, which would be a problem. But once you set it equal to 0, once you make this equal to 0, now you can clear the fraction. Okay, so clear fractions. It doesn't work on just anything, but on an equation, it does work. So I'm just going to erase all this homework so that I can use this space for writing. Oh, I can't erase the number. All right. So I clear the fraction. I get 0 is equal to, I'm going to distribute that too. 2 times 1/2 is x squared. 2 times 5/2 is 5x. And 2 times 3/2 is -3. Why was I able to do that? Because 3/2 times 2 is really times 2 over 1, which would give me 6 over 2, which is 3 if you want to see it long ways. But most people just do this and then jump straight to the 3. That's how you clear a fraction. So you start to factor. It's got to be x and x. It's got to be 3 and 1. Those are the only choices. But no matter what you do, positive, negative, 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 positive, positive, you're not getting a 5 in the middle. So does that mean that you can stop? Heck no. All right, if you cannot factor, or even on a problem where you should be able to factor and you just can't figure it out, you have to use the quadratic formula. If you can't factor. And it's an x squared. You can't use the quadratic formula. You can't use the quadratic formula on a cubic equation. And it's an x squared. Use the quadratic formula. Honors has to have it memorized. If you are in CP, you should write this whole green sentence and the actual quadratic formula, which is if you given this equation, given 0 is equal to ax squared plus bx plus c. So when you have a formatted equation like that, then the x solution would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Or, if you think you're going to get it wrong, negative b over 2a. Some people do this whole thing beautifully and then they simplify wrong. If you are one of those people, you should write it separately. And then your chances of simplifying it wrong are much smaller. So let's do that. So I can't factor, so I'm going to use the quadratic formula. X is opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is negative 5 plus or minus the square root. So 25 plus 12 is 37 all over 2. Again, are you allowed to leave this as your answer? You are, but keep in mind that if it was an x-intercept, what would that mean? That would mean negative 5 plus the square root of 37 over 2, comma 0, and negative 5 minus the square root of 37 over 2, comma 0. So I don't mind this plus or minus as long as you understand it represents two distinct answers that you could figure out. Okay. Like I said at the bottom of your homework there, you will need the quadratic formula for 33 on your homework. So I would add this to your appendix so that you have it. And great job today. Have a good one.